Good morning, dear students. Welcome to this session on pre-stressed concrete structures, where we are talking about pre-stressing steel, so high-strength steel particularly. So we have been talking about their properties, and last session we have talked about permissible stresses. I'll just run through the slides. So we have talked about clause 19.5.1, which tells about allowable stresses in pre-stressing steel, and you shall note that the uh, maximum tensile stress immediately behind the anchorages shall not exceed 76% of its ultimate tensile strength of either wire or bar or strand. Okay, and that is the limitation on initial pre-stress, whereas and there is no upper limit for the stress at transfer. Okay, uh, so that we have talked about, and the IS code recommendation on yield point, where 0.2% proof stress is taken as yield point for high strength steel, and also the curve given in IS code and related explanation in clause 23.1.1F, where figure 5 you have to take care of to take the stress strain properties of steel and also its dependency on the treatment process is also being discussed, and also a design curve, how to obtain design curve. It's just by dividing the material factor of safety. Characteristic curve shall be divided by the material factor of safety. For steel it is 1.15. Okay, and coming to relaxation of stress in pre-stressing steel. Okay, so this session we shall talk about this one. So relaxation of steel means what? So relaxation of steel is defined as the time dependent increase in strain at a constant stress. Okay, so what does this in fact, how do you feel this relaxation of steel means? So we pull the steel rod and tie it to the abutments, and over the time, maybe 1 month or 6 months or 365 days, like 1 year. So likewise, as time progresses, even though you are not pulling the wire with the additional force, just pulled once and then bolted, left it for some time, uh, once the time progress, you can see that the strain in the steel wire is still increasing. So the tightness that you have made by pulling the wire will be losing over the time. That is what is called relaxation of steel, relaxing. Okay, so what is this? Due to the relaxation of steel, what happens? The pre-stress in tandem reduced with the time. Okay, so this is what is the effect of this, because the strain is lost, hence the stress is lost. Okay, that is direct relation. So the study of relaxation is important in pre-stressed concrete to calculate the loss in pre-stress. Okay, so that is the importance of the relaxation, because when you lose the pre-stress, there is no point in using that member as a pre-stressed concrete member. And relaxation depends on type of steel and initial pre-stress, how much is the initial pre-stress you are inducing, and the temperature. Okay, and this diagram shows that the nature of loading also. When you load it very fast, quickly, say for example, you are applying some 1000 megapascal stress in the steel, say, just for example. Okay, this 1000 megapascal is achieved maybe within a span of 1 hour. Okay, or this 1000 megapascal is applied with a span of 24 hours. Okay, so this is the difference. This is a quick loading, and whereas this one is of sustained loading, very slow way of applying the load, rate of loading in fact. So fast rate of loading, slow rate of loading, that also depend on the effect of relaxation. So fast loading will have high effect of relaxation, whereas slow loading or loading rate will be of low impact on the relaxation. Okay, so the pre-stress shall be induced very slowly, right? Right, coming to the this diagram. Okay, so the values are normalized with respect to initial pre-stressing force. Okay, that means the pre-stressing force, that is like yield stress, fpy. Okay, and fpi, this is initial pre-stress, and yield stress in the pre-stressing steel are put in terms of a ratio, just a number. Okay, so initial pre-stress, and this is the characteristic strength of this one, or something like fpy, let us say yield stress. So if the yield stress values, the initial pre-stress value that you apply is say 50% of its yield stress. Say if it is, for example, the yield stress is 1000 megapascal for a particular steel. Okay, and if you are applying 500 megapascal, mean 50%, or no, 60%, 70%, 80%, 90%, likewise. So this is the way that you are applying the pre-stress value. Okay, so there is significant relaxation loss when applied stress is more than 70%. Okay, of the yield stress. So these are the lines drawn for the the different FPI by FPY ratios. Okay, so initial pre-stress is 70%. So this line is 60% line, 70% line, 80%, then 90%. So this shows the loss value is more, and this shows that there is no loss at all, almost nil, zero for 50%. And this is like time in hours taken. Okay, so there is significant relaxation loss when applied stress is more than 70%. Okay, so once this is more than 60%, the line is now just bending down, which means the stress is getting loosened or lost. Okay, so that is the point here. Okay, so the stress value also matters here. The one thing, the way you apply the load matters, and also the amount of stress also matters. Okay, and that is given in this table. The upper limits of relaxation loss should be like this. So cold drawn, form of steel also is mattering here. So cold drawn stress relieved wires shall not have more than 5% of initial pre-stress is the limit for relaxation loss. Even indented wires, stress relieved strands, and if it is bars, there is a value given, not in terms of percentage. It is 49 Newton per mm square. Okay, right. And coming to the IS code, what it will talk about on relaxation losses. You can see clause 19.5.2.3 talks about this, and table 6 particularly gives you the values of relaxation losses for pre-stressing steel. Okay, and initial pre-stressing stress is 50% of its characteristic strength, and you can see there is no relaxation loss at all, 0%. And if it is 60% of the characteristic strength of steel, which means, so for example, if it is 1000 is the characteristic strength of steel, if you are using only inducing 500 megapascal, relaxation loss is zero. If you are using 60% stress is induced in this tandem, then there will be loss, and that is what, how much you lose, 3% of the initial pre-stress that you are applying the value. Okay, so 3% of the stress is lost, like say 500, 3%. Okay, 150 is lost likewise. Okay, and 5% is lost. Okay, if it is 70% of stress is induced, 80% it is 8% is lost, right? So likewise, you have loss is more, relaxation loss is more if you induce higher value of pre-stress. That is the point here. Okay, so this is normal relaxation, and this is for low relaxation steel. We have a form of steel called low relaxation steel also. The limits also given for that also, right? Right. So that's about relaxation loss. What is relaxation loss in steel? So relaxation is a property of steel when you keep the tendon at a constant stress. Even though you don't increase the stress, strain will develop in steel. That is called relaxation of the steel. What happens with the relaxation property? You are losing the stress. Hence, you are losing the pre-stress value, and you are losing the effectiveness of pre-stress. Okay, so that is to estimate what is the effective pre-stress value. You need how much is the loss. Okay, so that is depending on the rate of loading and amount of load, I mean amount of stress, load in the sense stress also, and there are some upper limits given and also available in the tabular form. Table 6 in IS code, keep open your IS codes, you can see this clause on relaxation losses. Typically at 1000 hours time, 20 degrees centigrade. Okay, so coming to cover requirements for steel protection. Okay, and the related IS code classes are class 8.2.3 will talk about cover, and also 12.1.6 also talks about the covers. Okay, so protection of steel in concrete against corrosion depends on adequate thickness of not just concrete, good quality concrete. Okay, so steel, remember always protection of steel depends on the adequate sufficient thickness of good quality concrete, not just concrete. Okay, and nominal cover to the reinforcement shall be provided as per IS 456, which you have come across in your reinforced design of concrete structures, which is in class 26.4 of IS 456. Okay, so these clauses are for this IS 1343, right? And coming to that clause 12 and 6, what it say? So what is a nominal cover? Is the design depth of the concrete cover. It is the dimension used in design and indicated in drawings. Okay, so that is what is nominal cover. And there are two requirements here. One is a durability requirement, and another one is fire fighting requirement. Okay, so this is one such table, and we'll talk about fire resistance, another one. Okay, so these are the two things that you need to remember whenever you say nominal cover. So you have to think of durability and also fire resistance. These two will decide the nominal cover. So minimum values of nominal cover which should be provided in post-tensioned work shall be minimum clear cover from duct. Post-tension means you will have a duct. Okay, if the member is a post-tensioned one, what do we do? We'll provide a duct for inserting the steel. Okay, so at least equal to the clear cover means the concrete that is available till this location shall have at least equal to the diameter of the duct. So the diameter of the duct, whatever you have provided, that much shall be at least shall be given as a clear cover. Okay, so this is what is a minimum requirement. Okay, right. In pre-tensioned work, that is for post-tension. The cover of the concrete measured from the outside of the prestressing tendon shall be as per table 16 of IS 456. Okay, that means period of fire resistance shall be given as per table 16A. Okay, so both table 16 and 16A of 456 will decide the clear cover for pre-tensioned work. So post-tension work, it is clear. You have to maintain the dimension of diameter of the duct or sheathing as the clear cover in post-tension work. And if it is pre-tension work, and this is the durability requirements given in IS 456. Okay, depending on the exposure, durability. So mild, you need minimum 20 mm. Moderate exposure 30 mm. Stable 16 famously known as nominal cover to meet the durability requirements. If it is severe 45 mm, provide very severe for 50 mm cover, and if it is extreme conditions, provide 75 mm cover at least. Okay, so this is the requirement of clear covers to meet the durability requirements. Okay, and for fire resistance, table 16A will provide you the information. Okay, so that we will see here. So fire resistance for a period of half an hour, 1 hour, 1.5 hour, 2 hours, 3 hour, 4 hour fire resistance. So we will measure fire resistance in terms of time period for resisting the fire. Okay, so if it is for beams, okay, and simply supported continuous. So we mostly have this case of continuous. So if it is for half an hour fire resistance, you need 20 mm, and 4 hours if it has to resist. Typically, it is 50 mm. Okay, right? So this is the requirement uh, for fire resistance. Okay, similarly slabs, columns. Okay, it is minimum like 40 mm cover is required. Okay, right? So this is regarding fire resistance requirement. So whichever is more, we have to adopt that clear covers. Okay, so protecting steel depends on how good is the quality of concrete and how well it is covered. Okay, which means whether you are following the nominal cover requirements in both aspects, both durability as well as fire resistance. Okay, so durability requirements, they are clear according to exposure. Okay, and if it is fire resistance point of view, so whatever it is, finally a minimum of 20 mm is almost always required. A minimum of 20 mm clear cover is always required. Okay, in any case. Right, let us see other two properties, maybe out of your discussion, out of your syllabus content, whatever it is, which are required for your pre-stressing operation, right? So, steel, fatigue, and durability. So, what is a fatigue? Under repeated dynamic loads, the strength of the member may reduce. Okay, so instead of loading once, checking its strength, say if you have a member, put a load and measure its strength. Say you have got some value X. If you apply the same load repeatedly, okay, maybe 1,000 times, maybe 10,000 times, 1 lakh times, the structure, I mean member may not take that much load. Okay, that is what is called fatigue strength. Okay, the reduction in strength is referred as the property called fatigue. Okay, so the in pre-stressed applications, the fatigue is negligible in members that do not crack under service loads. Okay, so if the member cracks, fatigue may be concerned due to high stress in the steel at the location of cracks. Okay, right? So only for cracked members, when you allow, there are three types of members in the pre-stressed members. Where one which we don't allow any tensile stress, which is zero, no cracking, uncracked sections. Then second one, we will allow some tensile stress to develop, and also there won't be any cracks. Okay, and third one, we will permit cracked members to a certain limited tensile stress values. These are three types of members. Okay, so specimens are tested under these many cycles, 2 into 10 power 6 cycles of load to observe fatigue. Okay, so for steel, fatigue tests are conducted to develop the stress versus number of cycles. I mean, famously known as SN diagram. Okay, stress versus number of cycles. Okay, so under a limiting value of stress, the specimen can withstand infinite number of cycles. That limit is known as endurance limit. Okay, so if you are applying say 1,000 megapascal for 2 into 10 power 6 number of cycles. Okay, okay, right, member failed, then come down to 900, come down to 600, 500. If it is sustained by 2 into 10 power 6 cycles, then that 500 is called endurance limit. And in fact, it can take any number of cycles beyond that. Okay, this is the testing machine. If you happen to visit very nearby NIT Warangal, you can see that the no, uh, cyclic testing, okay, fatigue testing machine also, right? Almost IITs will have this machine, fatigue testing machine. This shows the fatigue setup. These two hydraulic jack operations will try apply the Fatigue testing mean repeated load of a particular value onto the member, concrete member. Okay, so that will do the purpose of repeated load of same value. Okay, and that you put it in terms of a graph. So where for how many cycles the member started failure. Okay, right. Durability. So pre-stressing is susceptible to stress corrosion and hydrogen embrittlement in aggressive environments. So hence pre-stressing steel needs to be adequately protected. Okay. So bonded tendons. The alkaline environment of the grout provides adequate protection. Okay. So the alkaline environment shall be provided. This is the prime need for us. So which will do that epoxy coating or galvanized bars or encasing in tubes, okay, and mastic wraps. A grease impregnated tape, you if you just can wrap around the steel bars, they can give you the protection over this and environmental aggressive environmental no attacks, and it can improve the durability. So prime is epoxy coating, or else you go for mastic wrap, or you go for galvanized bars, or encasing in tubes can be uh, can do the purpose of protecting from the aggressive environments. Okay, so this is about durability. So that's all with the case of uh, high strength steel properties, where we have talked about much of them. Okay, so from next session onwards, we'll move to the next content. Okay.